Hi, right now we're in the middle of another video, but I just wanted to take a little side quest to fix a bug that I realized exists in the language regarding GADTs. I haven't actually stumbled upon it, rather I just thought about it and realized that the implementation is wrong. So we're going to fix it. First of all, let me show you what the problem actually is. And it's actually pretty simple to demonstrate, and hopefully I'm not wrong about what the error is. If I am, then this video will never be published. Now, as you can see, the type of this identity function is y to y, y arrow y. So if we actually use that here, you'd expect it would work, but it won't. We're passing this variable a, which is an int, into this id, and it's telling us that it's expecting y. So what's going on is that inside this function, it's not actually substituting the type variable y for i32, and that's a problem. So what we're going to do, after putting this comment, is going to the language and then fix this. And the problem is that the term substitution is pretty much substituting everything. I'll show you what I mean. Let's see, term subst. Whenever we encounter this tyvar case, it creates a... First of all, let me show you what's really going on. Let's inline what's going on in tyvar, which is pretty much this. And this x is the type variable itself, as you can see, this var thing. And once we substitute the node itself and create a new reference, then the substitution for that particular node will stop working. In other words, it's kind of like we are making it immutable. In order to actually make it work, we need to pass in the older reference. But if we did that, then we get the same error we did earlier, where in recursive functions that are being passed inside their own body, the type variables would start getting substituted, and that's a big issue that we fixed. We had to change how the term subst works just to make it work. So what we have to do is keep track of the variables in the for alls. For example, here we have this type for all, and if we have something like a recursive function which has for alls, we don't want to make the type variables. I mean, we don't want to make all the type variables immutable. We just want to make the type variables that are under for alls immutable, if that makes sense to you. So what we're going to do is first create a loop. Let rec f equals, also let's make it a. Now we factored out the loop. This top level function doesn't need to be recursive anymore, and we're going to make use of a hash set. Hash set. Okay, generic collections generic. What's going on? Okay, system collections generic and hash set. And with this hash set, we'll store the for all variables that are under for alls into them. One option usually would be to use a immutable F# set, but the problem with that is that the type of this. First, let me put in a bookmark. Now we'll go into this. If I go only into this varting, and you see that it has this reference equality annotation. And that means it doesn't have a structural equality, but just reference equality. So unfortunately, we cannot put it into an immutable set because that set relies on comparison. Instead, if we have reference equality, if we have a type that's compared using reference equality, we have to use the imperative hash set. But it's not really a huge deal. Now let's go back. Not here, not here, not here. How many bookmarks? Okay, finally. I guess we'll just make it hash set hash identity reference. I mean, do we really need the... I guess we do need the system. Okay, fine. Now, here's the type for all. We'll add the for all variable into the set. And on the way back, we'll remove it. Remove the... Yeah, I like this. Now, I mean, do I also have a var here, maybe? Yeah, I suppose we should be doing it in type variables as well. Okay, let's make a little helper function to actually automate this. Let G A F H add A, and this will just be yeah, not bad. Now let's just do this. G A fun unit type, and then we'll just do this. We'll also do the same for a type enol here. In fact, one way of writing this out would be like this. Now it will be much easier to just copy paste it. Oh yeah, not bad. And we can also inline this so it doesn't allocate a closure. I mean, so it doesn't allocate f as a runtime closure. Oh yeah, no, not bad. And now we actually need to take advantage of that. First of all, here we have the type var, and we only want to actually substitute the reference if it's not in the hash set. In other words, we want to make it immutable if the type variable is under a for all, and we'll do that by replacing the reference with a fresh one. But otherwise, the type variable should remain substitutable. So let's see, if h contains, if it contains what, the type variable x, then yeah, then we should just make it immutable. Ref none, else Yeah. If it's under a for all, then it should be immutable, and we should just do this. Otherwise, we will leave in the original reference, so it can substitute it later. I think this is the solution to this problem. And other ideas that I had is to take a careful look at where turn subst is used, and maybe not to call it generalizing let statements, but who knows? It's not a solution that I like. It would be very error prone to try to control the term substitutions that way. Oh yeah, not bad. Okay, let's finally build this project. We'll start the VS Code plugin. We have to make sure that we're starting it off in the compilation tests and not the ML library. And now we just Control F5 to start the plugin. Yeah, as you can see, it works now. It's telling me this is Y, but maybe it should be showing me I32. I'm a bit confused why that is not happening. But you know, even though it's Y here for some reason, we can just put in int or I32, and you'll see that we're not getting an error. So that's proof that this is actually Y. I mean an I32. And if I hover over here, yeah, it's showing me I32. So yeah, who knows? Maybe we should try to figure out why this A is showing up as Y. And oh, here it is showing up as F32. Interesting. And if we remove the ID, oh, here it's showing up as I32. Oh, okay, I see. Okay, well, I'm not sure whether this is worth fixing at all. You know, maybe it's somehow unifying this Y with the meta variable A's, and that's causing trouble for some reason. Yeah, basically, why is this happening? Because the type hovers are getting the type that's actually known at this point in time, which is Y, and once it unifies it with that, maybe it doesn't really go any further. Anyway, it doesn't matter. What really matters is that the test actually works. Maybe we'll fix this type hover error later. Right now I don't have any good ideas how to deal with this. I'll have to think about it. And yeah, that's about it. Of course, we cannot just release this fix right away. Let's at least see whether the ML library still works. Like, we shouldn't be adding any new errors with this change. Okay, we'll comment this out. Now let's see. Problems? No problems. Okay, let's try. Yeah, let's go into layers. Okay, can we actually compile this spinal build file? Let's take a look at the terminal. It's not crashing, and that's always a good sign. Okay, I think this fix is fine. And this is okay, so what do we write here? Fixed how the type variables are being substituted when not under for alls. Oh yeah, nice. Now the way to actually publish this on the VS Code Marketplace, we can close this and go into this publish script and then just run the PowerShell script. Yeah, great. And this will be out on the VS Code Marketplace in a few minutes. Oh yeah, so that's about it for this video. The other video, I'm kind of getting distracted with various things, in particular with going to the beach and getting some exercise. So the progress has been slow. There's also been a huge heat wave. So, you know, making this separate video should give me an extra 4 days to finish the other video. I don't really have a goal of making a strict release cadence on YouTube, but it's better to have it than not. So maybe throwing in an easy video every once in a while like this is not a bad idea. If you like this, please like and subscribe, and I'll see you in the next video. Bye bye.